Okay, so since most of you are already here, so let's start today's leisure brief introduction to brief update of current AI. Sorry, it's Chinese. But it says is the AI singularity is coming, or the ChatGPT, the history of ChatGPT and the applications. So what will happen in the future? Actually, I don't know. If I know, I will all in TSMC or Nasdaq, and I don't need to be here, right? Buy and hold forever. Anyway, I find a group of people that can predict future quite accurately. They are sci-fi writers and the movie makers, right? Sorry, let me make sure that I'm recording. Okay. So let's take a look of the sci-fi movie that come true. The sci-fi movie technologies that are real today. Okay, so at least several technologies. The first one is the Jetsons, which is a cartoon, right? And it predicts in the future that there will be flat screen TV, right? Flat screen TV. So it's made in 1962, right? 1962. That's almost 60 years ago, right? So yeah, so it's come true today. And then the next one is also the Jetsons, so it's about the smartwatch. Now today we have Apple Watch, also Android Watch, but not many people are wearing Android Watch. Anyway, so we can communicate through the smartwatch. That comes true today. The next one is Roomba. Although the Roomba that day has an extra head, which is not necessary, but indeed we have cleaning robots almost in every household today. The fourth is a novel called The Visit to the World's Fair in 2014. The movie is published in 1964, so it's predict that, in 50 years, it's predict in 50 years in the future. Okay. Okay, so this movie predict that if you join the World's Fair in 50 years in the future, what will you see? So it's imagine that in the future there will be a coffee maker. Today we have coffee maker in 7-Eleven, right? And the next several technologies comes from a famous series called Star Trek, right? Star Trek. So that many technology leaders that admit when they were young, they watched the Star Trek. So when they growing up, they try to realize the technology in the films, right? That's how the prophet becomes true. So the Star Trek, the first one is the flip phone, right? It was very popular. Actually, the first flip phone made by Motorola is called the Star Trek, as far as I remember. And it's largely disappeared after iPhone has announced, but it's coming back, right? It's coming back. Samsung or other company are making flip phone again. Another one is that in Star Trek, all the computers are flat, like a tablet, right? So you see that Steve Jobs must have watched the Star Trek before. The pose and even the hairstyle are all the same, right? So Steve Jobs must watch the movie, the films, to gather the idea of develop iPad. Next one that is the Google Glasses developed by the founder, Serge Brin, I suppose. He admits that his idea comes from Star Trek. So here's a Google Glass that you can record and project some information in a small screen. But this product is not popular because it's somehow the invasive, right? It's offensive about other people's privacy. Also, it didn't success. Next one is comes from a famous sci-fi movie called 2001 Space Odyssey, right? Odyssey. It's a very innovative movie. It is actually is project AI, right? Like betray human. In this movie, we can talk about later. So in 1968, they imagine there's a video conference. Today we have video conference everywhere, and they are making video conference with Earth, with people on Earth, from space. So in the same movie, it's a great movie, although it's very old. There's an AI called HA 9000, right? If you have watched the movie, and they have a special mission to Mars, or they find a mysterious rock or something else in Mars. So the human fly to the Mars with the AI, or AI control everything. And somehow the AI information is misaligned or mismatched with the human information. Right? So the human decide that the AI has some problem, some issue that they need to turn it off, or they need to turn it off. But in a spaceship, right, every conversation, every videos, every conversation are recorded by AI. So they go to a small chamber, close the door, and talk together. However, the AI can your lips. They can recognize your lips. So the AI find out that human try to turn it off. So then the HA 9000 try to kill human. Okay. But finally it failed. We are still smarter than AI. Yeah. Okay. So next, another breakthrough last year is that we can now do space travel. Right? You young guys can do space travel in the future. Only if you are rich, of course. However, it's possible. It's possible, not impossible anymore. And you will have three options. You have three options. First is the Blue Origin, the company founded by Jeff Bezos, the founder of Amazon. It has a capsule on top of the rockets. It's more like a traditional rocket, right? So the competitor is 6. So 6 person is automatically. Yeah, it's fully automatic. So it does not have a pilot. Also 6 person in a capsule and go up to around 100 kilograms above the ground and have experienced like 5 or 10 minutes no gravity environment, then go back. It's a short travel. Another one is called Galactica. Okay, so it's found by Virgin Airline, Virgin Galactic, under Bronson, because this is the boss of Virgin Airline. So their space travel is use airplane, and big airplane will. I'm not pretty sure, but suppose a bigger airplane carry a small airplane, and then on some altitude, the small spaceship will by itself. So the total trip may take more than 1 hour, so it's worth your money. The last one is Musk SpaceX. Of course, we know SpaceX can do real space things, shoot the satellites, and then this can travel as far as to the moon and then come back. Also, it's a real space travel. So let's take a look of the video shot by the Branson, Virgin Galactica.
To all you kids down there, I was once a child with a dream, looking up to the stars. Now I'm an adult in a spaceship with lots of other wonderful adults looking down to our beautiful, beautiful Earth. To the next generation of dreamers, if we can do this, just imagine what you can do. Yay!
Yeah, okay, so if you have money, you can do a space travel in the future. Or you can donate to our school, it's your choice. Yeah, welcome to donate my lab. And the next innovation is autonomous vehicle, right? There was a famous film called Knight Rider. It's very old. You must be old enough to watch this video. It's very old.
现在我们这个无奇不有的世界，刀枪不入，无所不能。霹雳游侠李麦克充满正义感，是一个英勇的自由斗士。他以无比的勇气、超人的智慧，打击犯罪，拯救善良无助的受害者。
Yeah, so it's a old video. It's a video at my time. Now we have full self-driving, and I'm pretty sure in the future we can talk to your Tesla soon. If you're boring, you can use the internet to talk to ChatGPT. So here is what you can see when you buy a Tesla for self-driving. So it's a label. Of course, it sometimes fail. So you can use your life to debug for Tesla, and also you pay for it. But I'm sure it's become more and more safer because there are many volunteers. So yeah, so maybe I will buy one to test it, but I won't buy for self-driving unless they guarantee that they will buy insurance for their product. Right, so for self-driving, if there is any car accident, the car company should take the responsibility. Right, but so far, Tesla brand the drivers for any accident. Okay, so another one for the Chinese, the Doraemon. I predict that in the future there will be a magical machine that can draw comics automatically. Yeah, like what? Stable diffusion, like stable diffusion or mid-journey. Just so now you enter text, you can use to enter text and then ask a mid-journey or stable diffusion to generate comic books. So it's possible now. So we can try to imagine the future. So do we have now? Of course, first AI. And we have IoT. We try to connect everything together to the internet, even our fridge, our robot, Roomba, our phone. The next one is our brain. Maybe, yeah, we can connect our brain to the internet and all the things are finalized. So we have big data and we have robots. Talking about robots, most famous robots are Boston Dynamics, right? It's now we have 2 Boston Dynamics spots in this building. So maybe you can play with it. It's not mine, so I cannot guarantee that. You can control it with Python. Yeah, I remember its retail price is $70,000. So just like Tesla Model Y. So if you don't want to buy Model Y, you can buy Boston Dynamics Spot instead. But the company has been bought by a Korean company, Hyundai. So it's now a Hyundai company. Always see they are dancing most of the time. Right? The humanoid is not commercialized, so it's still because you need to program every movement of the robots, so it's not quite useful. Of course, I think they are improving very fast. Okay. So what do we have with AI plus IoT plus robot arts? Which movie reminds you? The Terminator, right? Everybody think about Terminator, the Judgment Day. So, but don't be too pessimistic. Let's skip the end of the Terminator. Since so many people are reminding human about the threat, so I believe the smart guys will take care of this issue. Make sure that AI is under our control, right? Become our slave somehow. Okay. So there's a famous terminology, famous idea called singularity, right? It's proposed by I.J. Good. I.J. Good is a mathematician. The idea is simple. Since 19,000, right, the technology accelerates in an exponential speed. So as you know, the Moore's law has ignited the development of deep learning. Deep learning especially needs the speed of silicons. So from the mechanical switches to the relay to the vacuum tube, transistor, and the integrated circuits. Here's the exponential order. Our computing power grow exponential. Of course, most of that facilitated by TSMC, right? Taiwan Semiconductor company, manufacturing company, and now NVIDIA keep the more slow going, right? So somebody say that AI is our final invention. Not only many smart people are care about this. Here's the Stephen Hawking. One of the smartest physicians after Einstein, and he said that AI could be the end of human. But he passed away a few years ago. Anyway, he tried to remind us. So of course, everybody knows Elon Musk, right? He says eventually robot will do everything better than us. So it's a greater risk than North Korea or Korea. Okay, so AI is a fundamental risk, so better under his control. What he means, right? So okay, so let's don't be so pessimistic. Now let's talk about what is AI, right?
那 AI 这个名
Okay,
词
sorry,
是怎么来的？
scary. That's not AI, is my voice. Let me turn off it. So here's the origin of AI. Those two scientists, Marvin Minsky, AI lab MIT AI lab founder, and John McCarthy, Shannon, or other famous people, they have a meeting in Dartmouth, and then and they create the name artificial intelligence. Okay, AI is a term, umbrella term for many for machine learning. Machine learning is about how to teach machine to learn. And today's AI is largely based on deep learning. and the deep learning is a branch of machine learning. There are still many other technologies, many other algorithms in machine learning that can do something that deep learning cannot do, or more efficiently. So the basic difference between machine learning and programming is that programming, we develop the rules. The programmers write down the rules, and the machine execute the commands. And then when there are data input, or the program generate the answers or designed by the programmer. But for machine learning, we input data and the answers, right? Sometimes no answers, but we need to enter the metric to evaluate the performance. And then the algorithm, machine learning algorithm, will learn the rules or learn the rules for us. Okay. So basically, machine learning can be classified into 3 categories. One is supervised learning. Supervised means there's a teacher that teach the machine learn. Actually, there are a lot of workers that label the data, label the image. For example, label if the image contains dogs, cats, or human. So there are a lot of human labeler, label the data. And so the supervised learning. Another one is unsupervised learning, does not require any labels. It's more intelligent and more close to AI, but the performance is worse. And so it's not very popular. Another one is reinforcement learning. It was very popular due to AlphaGo. AlphaGo beat the Go champion, right? Li Shudong. However, it's still, it requires the environment for learning. It's like a baby learning to walk. So you need an environment to trial and error, try and fail. And then you need to give then the reward. So it's about reinforcement learning. So for the supervised learning, it requires a lot of data labelers. Of course, I can to experience how to be data labeler, how we can label some data as a homework, right? So you see there are a lot of labelers. Okay, and sorry, I need to somehow hide this. Why not? Why not? I used to be able to hide this. Sorry, we can leave. So it's that's an important idea called self-supervised learning. Self-supervised learning. It's learning between supervised and unsupervised learning. Here's a slide from Yalakan. Because supervised learning requires too many human labelers. And sometimes you don't know how to label the data, or how to label that. But unsupervised learning is not reliable. So there is a new idea called self-supervised learning. They use structured data, like the articles on Wikipedia, right? The articles from Wikipedia are structured data, but they try to hide some words in a sentence and ask AI to predict the words. So it's unsupervised because we don't need to label, but it's somehow supervised because the articles are made by human already. They have some structure, so they call it self-supervised. Okay. So as you see, there are many different ways to do self-supervised learning. This is how we train ChatGPT, self-supervised learning. We can use future data, predict the future data from the past, or predict the future from recent past, or predict the past from present data. We have the data, but we hide the past data and use present data to predict it. or predict from top to bottom. Okay, so the key idea is these red words. The idea of supervised learning is that you have a structural data made by human, and you pretend that there is a part of the input you don't know and try to predict it. So you have the answer already. You have the ground truth because you have all the data, but you pretend that there's a missing part of the input, and then you try to train AI to predict it. Once the AI has enough data, they will learn something else. Okay. So this page less and less important. As I try to remind you, in addition to deep learning, there are different types of machine learning. The first one is evolutionary. Remember the famous quote from Darwin that the fittest survive, right? So it's about evolution. And then the connection. Connection is a deep learning. About the connection between the structure. So we can see those pictures on the first evolution is about the structure between different neurons, cells. And then the connection is the care about the learning the parameters. And then the symbolist, it was a popular range of machine. We try to find rules like decision tree. All the rules by the symbolist can be understood by human. So it was very popular. But today, actually, the rules, deep learning, although it's very, because there are too many parameters, so we cannot see all the data, all the rules. But actually, somehow we can still visualize part of the results. So it's not a total black box. Another one is the statistic. Use the Bayes theory, also about statistics. So here is the histogram. And then analogizer. Analogizer try to compare the input. You extract the feature first, and then compare with the training data, or to see which class you are more similar to it. So it's try to analogize. So there are some branches of machine learning, like the most representative algorithms of machine learning, like the decision trees, random forest for symbolist, and the Bayesian for the Bayesian, naive Bayesian. For analogizer, it was used to be very popular, the SVN or K nearest neighbor algorithms. For evolutionary, the genetic algorithm, and the connection is the deep learning. Okay, so the good news is that all the three algorithms can be reduced to three basic operations. What are that? It's actually a basic logic operation. If you have taken, logic design or a computer architecture, computer organization, you know that our computers are designed by those logical gate, right? Boolean algebra. So suppose we have input only 0 and 1. 0 and 1, because it represents switch on and off, power on or power off. So 1 is signal, 0 is not. And the AND gate means that only two input are 1, then output will be 1. If one of them is 0, then output is 0. And OR means that either input is 1, then output is 1. Or not is the reverse of the input. So all the algorithms can be reduced to the three operations. All the algorithms can be run on computers, should be able to reduce to the three operations. But there's a special type of operation called XOR. XOR is looks like a fundamental gate, but it's not. It's called exclusive OR. So the difference that is the inverse of OR. Where there is OR, output is 1, but when the input are both in 1, then it will be 0, exclusive OR. So only OR will output 1. Otherwise, both 0 or both 1s will lead to output be 0. The XOR can be designed using the fundamental three fundamental gate, like this one, right? Okay, so XOR has a special status in the history of deep learning. So I mentioned it. We will see it later. So I guess most of you already know that the deep learning is resemble our neural networks. Why? It's try to imitate our brain. So let's take the picture. This is actually about neural networks. First, we need to understand the structure of our neuron. We have millions of neurons, billions, 100 billions of neurons in our brain. And each neuron looks like this. There was a nucleus and many connections to other neurons. So basically, one neuron will have a long connection called axon. And the axon will have a branch to connect to another neuron. The tree-like connection is called dendrite. And there's a synaptic terminals to save the status. So how many neurons are there in our brain? Have you ever wondered? For adult, usually there are 100 billion. Each neuron have around 1,000 connections. So the total connection is around 10,000 trillion. Right now, how many parameters does ChatGPT have? We don't know. But for GPT-3, remember they are around a billion is a gigabyte, right? 700 gigabyte parameters, also 700 billions. But it's a connection. So it still have this connection in human, but it's still very powerful and it's never forget, right? Anyway, for a neuron, so researchers to build a model for our neuron. Actually, it's very simple. It's only use the addition and the multiplication, right? So first, we have multiple inputs represent inputs from other neurons, right? And then second, each input has different importance. So we give a parameter, give a number to represent the importance of the input. We call it weight. So we use W. And then we just do weighted sum. So the base operation of neurons is very simple. It's just a weighted sum of the inputs from other neurons. But there's a key point. Let the output need to go through a nonlinear output, which means here's a system of nonlinear. Linear is just a line equation, right? This is nonlinear because if the output is less than 0, then the output will be 0, which means the switch, or maybe we can imagine it as a switch. The switch is closed. Otherwise, if the sum is larger than 0, then we output 1. So somehow we can convert the linear weighted sum to a nonlinear switch. You can control it to switch close or open, close or open, right? So with so many switches, you can remember how our brain works. This is a more modern model. For modern neural model, is really the same, but it's add a bias to control the threshold of opening or closing the gate, right? Actually, in previous work, there's a threshold controlled by the weighted 0. But here we specifically list a parameter called bias. So the weighted sum plus the bias. So you need to your input need to larger than bias, then the switch will open, right? Okay, and then we not just use the simple else. We can replace the simple if else with other functions. Those functions called activation function. So for modern neuron, that's just a weighted sum of the input plus a bias, and then goes through activation function, and then output the result. Okay, so that's the math model of neuron. Well, not too difficult. Okay, so the scientists have discovered after they developed the math model, everybody was very excited and studied. They think they find the mystery of human intelligence. At Minsky, the founder of MIT AI Lab, and also one of the member of the Dartmouth meeting, right? is the one who helped to create the term AI, artificial intelligence. He studied neurons, which he called the perceptrons at that time, as his PhD topic. So he published his thesis called perceptrons. So he's a pioneer of neural network. But his conclusion is that he was very pessimistic about the future of neural networks, and he think the perceptrons or neural networks may not be succeed, may not be succeed forever, may not succeed forever, may never, if may fail forever, may never succeed, because he lists a lot of examples. One of the examples that perceptrons can do XOR. So do XOR. Okay, because XOR is nonlinear, but a perceptron, a single neuron, is linear. So we think since perceptron cannot learn the so basic operation, then it can do many feats. Okay. So maybe I can show you why it's why it can do XOR. I can draw a picture. Well, suppose this is the output. This is the input A, and this is the input B. Both are inputs. Inputs are here. We have two inputs. This is input 0. This is input 1, 0, and this is input 0, 1, and this is input 1, 1. And for an XOR, the output should be 1, 3, dark, 1, 1, 0, 0, right? The output. So we cannot learn a line to separate 1 or 0. Okay, try. Use another color. So for linear function, we need to find a line to separate 0 and 1. Separate 0. However, we cannot find a linear line to separate totally 1, 0. We need two lines to separate output. So that's why a single perceptron cannot learn how to do XOR. That's the reason. Okay, so since the pioneer of AI said that neural network will never succeed, it's called the AI winter. Of course, the situation is a little bit more complicated than that, but indeed, it goes through 2 AI winter before. Who is the white knight? The hard time during the winter. Winter is coming. There are 3 great heroes. First one is Hinton. He's now considered the godfather of deep learning. Second one is Young Lacan. Young Lacan was the postdoc of Hinton. Yes, he is French. Benjio is also a French. Hinton is English man. Anyway, they all work in United States. So Young Lacan and Benjio, they are good friends, and they firmly believe that one day deep learning will be the key of AI, will be succeed. So during the dark time that everybody dismiss the neural networks, they insist on study neural networks. During the AI winter, the situation goes so bad that if your paper has the name neural networks, it may be rejected because people don't believe it. So somehow they change the name a little bit to deep learning, also get their paper easier to be accepted. Of course, another reason is that now we can do very neural networks. In previous time, it's not possible because of the computing power and somehow the activation function. So it's not possible to very deep neural network before. So here's the picture of the big three. There's a Nasha or Andrew is here. He's younger. He was also a believer of neural networks before. So they took picture together. So what did Hinton do? Actually, Hinton solved this problem when he was very young. So I find a young photo of Hinton. So Jovic Hinton first proved that to show everybody that learning XOR with neural network is possible. So he proved that Minsky was wrong. How? So actually, Minsky was partly right. That single neuron, single perception cannot learn XOR. That's true. But multiple neurons, and there are different solutions to learn the XOR neural network. Or there are multiple solutions that you can do XOR. So surprisingly, the answer is not too difficult, right? Just use multiple neurons. But the difficult part was that there was no algorithm to learn the parameters, to learn the weights of the. That's the part. Minsky also know that multi-neuron can learn XOR, but he just didn't know how, which algorithm can help to learn the parameters. So he think neural network will fail. So Hinton showed him how. So how to train neural network? Actually, we can. The algorithm is not too difficult to understand. As long as you have a high school math background. So to understand how neural network work, let's see a picture. So we have a lot of data, input data. Before, initially the weights are randomly, and we need to train it. The learning process in computer science, we like to call it a training. So we have the input data, and all the input data will calculate. We just do the weighted sum plus by, go through the activation function, right? We just keep doing that, calculate all the results. It's only about addition and the multiplication and some comparison. That's simple. And we can calculate it out. The output will calculate the probability of that the input image is of a dog or of human. Suppose that the neural network think the input image is dog, then we can compare with our answer. Answers are called labels. The labels is that those images are human face. So the prediction was wrong. And we calculate the difference, the probability difference, to calculate an error, and then we can propagate the error, which means that we go back to adjust the weights to minimize the error. That's called back propagation. So we go back to adjust our parameters, minimize the error. This is the process of learning. Once the training process was done, then we only do forward pass calculation. In prediction, we call it inference. In inference, once the model has been trained, we just do forward calculation. That's called inference. And suppose the will give us the right answer. So what's the back propagation algorithm? What's the metrical math model behind this? It's actually chain rule in calculus. Right? Chain rule can let you differentiate one function and then multiply with the other. It's very suitable for a neural network that have multiple activation functions, right? So of course I don't know the details, but basically we can use the chain rule to train to find the direction that we need to minimize error and then try to adjust the weights altogether. So let's take an example. Here's an example that trained a neural network to recognize handwritten digits. Okay, this is the hello world of deep learning. The dataset was created by Yang Naken. Let's watch a video. I recommend to watch a video from this YouTuber. Is called Three Blue One Brown. Oh, he has made a lot of great visualization of math. Let's take a look at the video. So suppose we have a neural network with 3 layers, and the input is an image which is 7. So our goal is to predict the probability that this input image belongs to which number from 0 to 1. And suppose if the network has been trained well, it's supposed to have give the number 7 highest score. Okay, let's watch the video.
This is a somewhat classic example for introducing the topic. And I'm happy to stick with the status quo here, because at the end of the 2 videos, I want to point you to a couple good resources where you can learn more, and where you can download the code that does this and play with it on your own computer.
When you try to count how many layers do you have in your neural network, you only count the connections. Connections are represents weights. It looks like 4 layers, but it's actually 3 because the first one is the input data. Okay, so here's how it looks like. It's called fully connected, which means each neuron has been connected to all the neurons in the next layer. So it's fully connected. So there are 7084, which is the number of pixels in MNIST. MNIST image is 28 by 28. And then there are 16 neurons, and finally output is 10, represents the probability of each number. We have 10 classes from 0 to 9. Okay.
Written digit recognition, the hello world neural networks. These digits are rendered on a 28 by 28 pixel grid, each pixel with some grayscale value between 0 and 1. Those are what determine the activations of 784 neurons in the input layer of the network. And then the activation for each neuron in the following layers is based on a weighted sum of all the activations in the previous layer, plus some special number called a bias. Then you compose that sum with some other function, like the sigmoid squishification or a ReLU, the way that I walked through last video. In total, given the somewhat arbitrary choice of 2 hidden layers here with 16 neurons each, the network has about 13,000 weights and biases that we can adjust. And it's these values that determine what exactly the network, actually does. Then what we mean when we say that this network classifies a given digit is that the brightest of those 10 neurons in the final layer corresponds to that digit. And remember, the motivation that we had in mind here for the layered structure was that maybe the second layer could pick up on the edges, and the third layer might pick up on patterns like loops and lines, and the last one could just piece together those patterns to recognize digits. So here, we learn how the network learns. What we want is an algorithm where you can show this network a whole bunch of training data, which comes in the form of a bunch of different images of handwritten digits, along with labels for what they're supposed to be, and it'll adjust those 13,000 weights and biases so as to improve its performance on the training data. Hopefully, this layered structure will mean that what it learns generalizes to images beyond that training data. And the way we test that is that after you train the network, you show it more labeled data that it's never seen before, and you see how accurately it classifies those new images. Fortunately for us, and what makes this such a common example.
Yeah, so this is a training process of trying to adjust the parameters, the number between the connections, the weights, and try to minimize the error. So how can we train the data? So we can use the backpropagation. First, we need to find the directions to move. So here's the idea. This is called gradient descent. So J of W is error function. And here's a single weight. We can change the weight like moving between this curve. Suppose our neural network has this shape of function. This is called convex function because it has a global minima. Anyway, so initially we don't know where is the global minima, so we randomly initialize the weight here. So we randomly initialize our weight here. here. And then our arrow, the J of W arrow will be here. So how can we decide where to move? We move up or shall we move down? We don't know, so we calculate the gradient. The gradient will show us the direction, and then we try to a little bit, like change the weight a little bit, and then suppose ideally we will go down a little bit, and then we continue this process until we stop here. When we reach here, we can find there's no obvious change of the error or accuracy, and we can say it's a global minima. It's a minima. It's a minima. In this case, because it's a perfect convex shape, so we have a global minima. So this is the idea of gradient descent. This is why we need the chain rule. The chain rule is to use to calculate the gradient. So find the direction and change a little bit, calculate the error again, try to minimize it. That's the idea of deep learning. It's actually easier than other algorithms. Some of the algorithms were very complicated.
Just imagine a simple function that has one number as an input and one number as an output. How do you find an input that minimizes the value of this function? Calculus students will know that you can sometimes figure out that minimum explicitly, but that's not always feasible for really complicated functions. Certainly not in the 13,000 input version of this situation for our crazy complicated neural network cost function. A more flexible tactic is to start at any old input and figure out which direction you should step to make.
Yeah, because this video is important, so let's finish it and then
How do you find
break.
an input that minimizes the value of this function? Calculus students will know that you can sometimes figure out that minimum explicitly, but that's not always feasible for really complicated functions. Certainly not in the 13,000 input version of this situation for our crazy complicated neural network cost function. A more flexible tactic is to start at any old input and figure out which direction you should step to make that output lower. Specifically, if you can figure out the slope of the function where you are, then shift to the left if that slope is positive, and shift the input to the right if that slope is negative. If you do this repeatedly, at each point checking the new slope and taking the appropriate step, you're going to approach some local minimum of the function. And the image you might have in mind here is a ball rolling down a hill. And notice, even for this really simplified single input function, there are many possible valleys that you might land in, depending on which random input you start at. And there's no guarantee that the local minimum you land in is going to be the smallest possible value of the cost function. That's going to carry over to our neural network case as well. And I also want you to notice how if you make your step sizes proportional to the slope, then when the slope is flattening out towards the minimum, your steps get smaller and smaller. And that kind of helps you from overshooting. Bumping up the complexity a bit, imagine instead a function with two inputs and one output. You might think of the input space as the xy plane, and the cost function as being graphed as a surface above it. Now, instead of asking about the slope of the function, you have to ask which direction should you step in this input space so as to decrease the output of the function most quickly. In other words, what's the downhill direction? And again, it's helpful to think of a ball rolling down that hill. Those of you familiar with multivariable calculus will know that the gradient of a function gives you the direction of steepest ascent. Basically, which direction should you step to increase the function most quickly? Naturally enough, taking the negative of that gradient gives you the direction to step that decreases the function most quickly. And even more than that, the length of this gradient vector is actually an indication for just how steep that steepest slope is. Now, if you're unfamiliar with multivariable calculus and you want to learn more, check out some of the work that I did for Khan Academy on the topic. Honestly, though, all that matters for you and me right now is that in principle, there exists a way to compute this vector that tells you what the downhill direction is and how steep it is. You'll be okay if that's all you know and you're not rock solid on the details. Because if you can get that, the algorithm for minimizing the function is to compute this gradient direction, then take a small step downhill and just repeat that over and over. It's the same basic idea for a function that has 13,000 inputs instead of 2.